Welcome to the Edge Evo hardware video. The purpose of this video is to get you up and running on Edge Evo hardware as soon as possible. Edge Evo has much in common with traditional Edge hardware, but there is an important new concept that greatly expands its capabilities. Edge Evo can expand modularly to downstream devices using a secure device protocol known as HIO. HIO is an abbreviation for Highly Intelligent Opening. This 4-wire bus enables fast, bidirectional, and secure communication to take place between components around a physical access control door. HIO permits increased versatility in the single-door solution. Edge Evo reader controllers are indistinguishable from traditional readers by appearance or thickness. Inputs and output capabilities are expandable and may be confined to the secure side of the door. A second reader may be added to any of the controllers for in and out reading capability. The most compelling features of the previous generation have not been changed. Edge Evo maintains its open architecture design as well as its ability to be powered and communicated to through a single Cat5 cable. All PAX systems start with the need to secure a door. Traditionally, this is done with an electrical locking device such as this door strike. Locking mechanisms are typically connected to a controller, which usually resides in an electrical closet in proximity to the door. Almost all locking devices are connected with 2 wires to the controller. In order to have a physical access system, we must have a device to read our credentials. This device, depending on how it is wired, is connected with between 4 and 6 wires to the controller. Shown here is a door switch which is also connected to a controller with 2 wires. The purpose of the door switch is to provide a real-time indication to the controller of whether or not the door is securely closed. Most door switches are composed of 2 components. The immobile component that is inserted into the door frame and connected to the controller, and the second component which is magnetic and moves with the door. A door being opened without a presentation of a card can be considered an off-normal condition known as a door forced open. Often, however, there is no reader on the secured side of the door. In order to inform the controller that an individual is leaving the premises and will need to open the door without generating a forced open condition, a device known as a REX or request to exit is installed on the side of the door away from the reader. This device is also connected to the controller with 2 wires. The REX is shown here as a transparency to clarify that it is on the secured side of the door, that is, the side opposite of the reader. The REX shown here is a manual push button, but today most REXs are of the passive type, requiring no action on the part of the person leaving. Shown here is a passive infrared type REX device. Because this device is powered, it requires 4 wires, 2 for power and 2 to signal the controller. This PIR REX, like the push button, is on the secure side of the door. Note that in traditional topology, all communication travels in only one direction. The reader, door switch, and REX all send information to the controller, and the controller in turn activates or does not activate the locking device. This unsecure single-direction communication results in vulnerability. If any of these wires, for example, the reader's Wiegand communication wires, are accessed, they could be compromised and unauthorized operation can result at the door. Edge Evo takes physical access to a new level of security. Shown here is the core product, the EH400 controller. Notice that the only communication connections on the EH400 are an RJ45 Ethernet port for connection upstream to the host and a 4-pin green connector port for the HIO bus that provides connection to all downstream peripheral devices at the door. The EH400 is connected to Ethernet as shown and is capable of deriving its power from a Power over Ethernet switch or alternatively from a Power over Ethernet midspan injector. Edge Evo is UL294 listed with any UL294 listed PoE power supply. If the power requirements of the door exceed the capability of the POE 802.AF standard, the EH400 provides for connectivity to an external power supply. Using the HIO bus with native HIO devices is intuitive. The HIO bus can be easily daisy-chained to a HIO-enabled I-class reader, door strike, door switch, and request to exit device, because every HIO device is aware of its specific role at the door. All devices are connected identically. Each device communicates with the controller securely and continuously. This results in an assurance of system integrity not attainable with traditional topology. It would simplify installation if the EH400 could be combined with a reader. This results in the EHR40. The EHR40 is an integrated controller and I-class credential reader. This device provides the same HIO bus connectivity as the EH400, which enables downstream devices for inputs, outputs, or even a second reader. The EHR40 may be employed along with the HIO-enabled ELM lock module to provide a streamlined solution for a simple physical access control door. The EHR40 connects upstream to the host through Ethernet and downstream to the ELM via HIO bus. The ELM is then connected to the door strike and may be configured for either 12 or 24 volts DC output. The ELM is compact enough to fit within the door frame and may reside next to the door strike. The EHR40 and ELM are bundled together as the EHR40-L. This solution provides all of the hardware necessary for an access control door that does not require a door switch or REX device and will only be reading high-frequency credentials such as I-class. If low-frequency credentials such as HID proximity are anticipated, the EHRP40 would need to be installed, which is capable of reading both high and low frequency credentials. Note that the EHRP40 and ELM are not bundled. If you require both items, you will need to order them separately. Note also that the dual frequency EHRP40 may be bundled with the EDWM-M. Both units together may be ordered as the EHRP40-K. The EDWM connects to the reader controller through the HIO bus and provides connections for traditionally wired reader, door switch, and REX. To show in greater detail, here is the reader controller in EDWM. When looking at the back of the reader controller, the device is indistinguishable from the controller by itself, the EH400. The reader controller communicates downstream to the EDWM through the HIO bus and upstream through Ethernet wiring. The EDWM provides the necessary interface to connect to any Wiegand protocol card reader, as well as any conventional door strike, REX device, and door switch. The EHRP40K provides an eloquent single-door solution when in and out readers are required at the door. Suggested practice is to mount the reader controller on the protected side and the Wiegand connected reader outside. Note also that the HIO bus is expandable. Here we can expand the bus in order to include two input modules, product model EIM-Ms. The HIO bus can accommodate up to 2 of each type of module. When a second module of the same type is used, it must be distinguished from the first with the group select jumper. It is important to understand that the amount of power available in a PoE installation is limited. Documentation is available so that you know precisely how much power is available and how much is consumed by each module. Some combination of modules, especially when the consumption of readers and locking devices are factored in, may require a separate power supply to power the controller or reader controller. For this reason, both controllers and reader controllers provide connections for separate power. The last Edge Evo controller to look at is the EH400K. The EH400K provides all of the connectivity of an EH400 and EDWM in one footprint without an integrated reader. The EH400K provides connections to an external Wiegand protocol reader as well as conventional door strike, REX device, and door position switch. Hi/O bus connections are also provided for expansion. Because so much technical information learned about the EH400K may be applied to other modules, we will look in depth at this versatile device. The EH400K is really a collection of three discrete modules: the EH400 controller, the EDM door module, and the EWM Wiegand module. Note that the EDWM that we previously looked at provides the functionality of both the EDM and EWM modules. Circled here is the Hi/O bus on the EH400 controller. Already plugged into it is the EDM on the left. If we followed the bus, we can see that plugged into the EDM is the EWM. There is nothing plugged into the Hi/O bus of the EWM. This connector would provide for any additional Hi/O modules to be added. Here you can see the specifications of the Hi/O bus, which again is appropriate for the area around a single door. The EH400K is connected to its host through Ethernet cable and can also be powered from this cable using PoE. If a PoE switch is not available, a mid-span device can be used by connecting the powered mid-span device between the switch and the controller. If we were to put a meter on the Hi/O bus of our controller powered by PoE, we would find the bus to read 24 volts DC. Because Hi/O is a daisy chain, no matter where we measured this Hi/O bus on the controller, or on any connected Hi/O devices, we would also find 24 volts DC. If we directly connected the controller to a non-PoE Ethernet port, the controller would need to be powered by an external power supply at this location on the board. The preferred power supply, the choice which provides the most power for connected devices, would be 24 volts DC. Notice that the Hi/O bus becomes the same voltage as the power that is supplied from the external power supply. Also notice that no matter what voltage the controller is operating at, the reader supply voltage is converted to 12 volts DC. This is because the vast majority of readers available operate at 12 volts DC. If we chose to power the controller with 12 volts DC, we would find our Hi/O bus to be at that voltage and again 12 volt DC available to our readers. The controller will work properly at any DC voltage between 12 and 24 volts DC. Note that no matter what the power within this range, the reader will be supplied with 12 volts. For the remainder of this presentation, there is an assumption that the controller is powered over Ethernet, and as a result, the Hi/O bus will be 24 volts DC. Connecting the external reader to the EH400K is done as it is to most controllers. The reader is powered with its red and black wires and connected to the data 0 and data 1 through its green and white wires. These four wires are the only wires that need to be connected for a reader to operate. The remaining wires perform other functions regarding beeper, light indication, and tamper functionality. Let's zoom into the lower left portion of the EH400K controller. The top three terminals are there for the unlocking device. They are labeled DS because the most popular unlocking device is a door strike. To display what is happening, I'm showing on the right the three DS connections. Anything displayed to the left of these connections are within the controller. Anything to the right would be connected external to the controller. As you can see in the default configuration, the connections provide what you would expect: traditional Form C contacts, normally closed, common, and normally open. This default configuration is silkscreened on the controller here, and the jumpers are arranged here. If we had a reader connected to the controller and a credential set up properly for access, presentation of that credential would cause the contacts to change state for the configured amount of time. Door strikes are configured within the strike one of two ways: fail secure or fail safe. If a fail secure strike is without power, it is locked. Conversely, a fail safe strike without power is unlocked. Assuming this strike to be fail-secure, we would need a power supply capable of operating the strike, and then would connect the strike to the power supply through the common and normally open contacts as shown here. This would enable a card presentation to energize the door strike, allowing the card presenter to go through the door. Magnetic locks are inherently fail-safe devices. Removal of power results in an unlocked door. Devices of this type should be connected through the normally closed contacts that are provided. This enables presentation of the card to de-energize the device for the configured unlock time period so that the presenter may go through the door. In both of these circumstances, the power supply is wired through contacts in the controller that are unconnected internally. For this reason, the contacts are considered dry. Wiring can be simplified and connections can be reduced by configuring the DS contacts as wet. This configuration is depicted on the silkscreen here. Jumpers should be arranged as depicted here. Taking this step internally connects 12 volts positive to the common side of the relay and ground to the common side of the output contacts. Connecting the fail-secure strike now becomes direct, without need to connect to a power supply. Wiring the fail-safe device is done similarly, only using the normally closed instead of normally open terminals. Another configuration option is to use the DS wet CAN bus option as depicted here and configured here. Doing so will send whatever voltage is on the HIO bus to the unlocking device. There is a tamper input on the controller. This may be connected to an external tamper device. If there is no tamper device, all tamper inputs on the left and right side of the EH400K must be shorted together. If an external power supply is being used, the AC fail condition can be monitored by connecting here. If the external power supply has battery backup, contacts reporting any battery failure may be monitored here. Any REX device would be connected here, and any door position monitor switch would be monitored here. Notice that there are also auxiliary output contacts on the controller that may be used to operate an external device. These contacts may be configured wet or dry, as depicted here. The jumpers for these contacts are arranged here. As stated previously, the HIO bus may be extended, often to pick up a second reader. The bus may also be extended to pick up more I/O, like with this EIM. The Edge Evo controller installation is greatly helped by making use of the status screen. To access the screen, the IP address of the controller is inserted into a computer browser. By viewing the screen, it can be determined in real time what modules are connected to the controller and what the status is of all inputs and outputs. This concludes the installer training on the Edge Evo product line. The remainder of this video will be concerned with Vertex Evo.